Here we're going to investigate the intermolecular forces between two carbonic acid molecules. Intermolecular forces are forces that hold any two given molecules together. There are four types of these forces: London dispersion, ionic, dipole-dipole, and hydrogen bonding. As you can see, to begin, we've already drawn two Lewis structures of carbonic acid. Let's start with London dispersion. London dispersion is a weak force, that holds any two given molecules together. Since these are any two given molecules, London dispersion is a force that holds these molecules together. Next, let's look at ionic forces. Ionic intermolecular forces is a force that holds together any two given molecules in which each molecule has at least one ionic bond. To tell if these bonds are ionic or covalent, we need to use electronegativity. We need to look at the electronegativity of each atom. The electronegativity of oxygen is 3.5, while carbon is 2.5, and hydrogen is 2.2. Now, we need to take the difference of each bond to figure out if they're ionic or covalent. So, for the bond between carbon and oxygen, we need to take the difference of 3.5 and 2.5, which is 1. For the bond between oxygen and hydrogen, we need to take the difference of 3.5 and 2.5, which is 1.3. Since both of these numbers are less than 1.7, all of these bonds are covalent. And since these molecules are identical, the same could be said for this molecule. Since there are no ionic bonds in these molecules, no ionic intermolecular forces are displayed. Next, let's look at dipole-dipole. Dipole-dipole is an intermolecular force that holds together two dipolar molecules. Electronegativity again can be used to tell if these molecules are dipolar. So, oxygen is heavily negative because its electronegativity is much higher than that of hydrogen. That can occur over here. And once again, since carbon is less electronegative than oxygen, oxygen is highly negative. Since we have two positive forces on this side and one negative force on this side, this molecule is dipolar. The same could occur in this molecule because it is identical. So, since these are both dipolar, the dipole-dipole intermolecular force is used. Hydrogen bonding is a subset of dipole-dipole. Hydrogen bonding is an intermolecular force that holds together two dipolar molecules in which a hydrogen bonds with a fluorine, oxygen, or nitrogen of another atom, another molecule. So, let's look at this. Since we have a positive hydrogen on this side and a heavily negative oxygen on this side, the positive can be attracted to the negative oxygen. And since this is a bond between hydrogen and oxygen, this is hydrogen bonding. To conclude, the intermolecular forces between carbonic acid are London dispersion, dipole-dipole, and hydrogen bonding. Ionic bonding is not shown.